Yo, yo, yo. So today's stream is gonna be filled with much the same as yesterday's stream. We're cleaning up and doing some prep work, moving some things around to make it possible to both render the water in a nice way, but also render the transition from no water to water in a nice way, which is probably gonna be quite hard, but hopefully this prep work will make it easier on us. So yesterday I introduced an enum that has been needed for a while, more specifically the terrain data type enum. Right now we only have height, foliage, and then we have 2 unused. And then the water, it takes up 4 spots in this, which I'm not that happy with. And we'll see what we can do about that. But if one takes a closer look at what the water actually is, we can see here that we have water, and then we have water previous, influx, and timestamp, where the latter 3 are only needed because we want to do some animations, which makes me think like maybe we could store them in a temporary texture later and let terrain data type be more for specific or static things. But yeah, it feels like it's going to be quite a battle to be able to pack the data, like memory versus speed. Like I want to put a lot of data in different textures, but I also want to avoid that type of stuff. But okay, let's see here. So the first thing I'm going to do today is I'm just going to add one of these methods, string, to be able to clean up the printing of information a bit. And for now, let's see here. For now, I think we can just do return type.toString. And then in get information here, we're gonna make it a little prettier soon. First of all, we're going to do terrain data container, get resolution, get information, get resolution. here. Remove some of these strings in the middle of things. Although I wonder, do we use this one? Yeah, I think we do. Yeah, I think we want to get rid of these as well. We want to get rid of these as well. Then we want to pack this one and this one in this one. We're also going to create these two. Yeah, we're just going to create this one and add these two. Yeah, it's going to be a lot of cleaning up today, but let's just do this, see where we use them. Set raw fluid amount. Apply. Yeah, that is one thing we need to do. Alter data. Get data array. Alter raw height, we want to get rid of this one as well. So what we want to do last in both set data and alter data is we want to call a method called apply. but we want to do it on, let's see here, we want to do it on only the altered texture. So do we have get resolution, get index? I guess it's to data type dot texture index apply, and this one we want to add to this one as well. So we alter the data on the we're gonna do it like this. Let's do it like this. Public void apply data. And I'm going to explain why. So we have apply data here. So we're going to replace this one. And we're going to replace this one. But I also want to make them optional. And it's going to be false by default. So when we alter the texture on the CPU, we also want to send that data to the GPU, because that's where we're actually going to use it in most cases. So when we just alter one pixel like this is going to be like worst case scenario. If we take like altering the height, for instance, we do the full alteration on the GPU, which is way better. But I'm not entirely sure just yet if we could take the full fluid solution and also put it on the GPU. So we're gonna have to rely on these for now. And when we do different steps of the fluid solver, we're gonna change a lot of values. And if we did apply between every such change, it would just be a lot of redundant applies, so a lot of redundant sending data to the GPU, while instead we can alter a lot of data, and when we're done with one iteration of the algorithm, then we can apply it to the GPU and render it. So now we have two ways to do it. So every time we call set data or alter data, we can set this one to true and we apply it, or we could do all these things and then in the end from the caller we call this one. And I think that's that's overall better, I would say. Inbounds, yeah, we have replaced these, but we only have, what do we have? We have inbounds here for both. We also want to check if it's bigger than 0. That's true. So inbounds, So both are bigger than 0 and both are less than their respective. And then we're slowly going to remove data primary and data secondary references here and only rely on data. And this is quite good. I think we could if we find a need for it, we could probably add an additional one as well pretty easily after this. Height range, this one fuck this one. So terrain data container is only gonna work with values between 0 and 1 on the GPU, or values between 0 and 255 on the CPU. Height range here is more something related to the terrain patch, and it's basically, so like when we store data in the texture, we make the value range between 0 and 1, but when we represent the value in the real or in the world space, we might want to change the height. So for instance, the height data will only have a value between 0 and 1, but in the world it might be rendered as between 0 and 20 meters. And previously I had a nice little getter for it in terrain data container, which we're going to name terrain data. But yeah, this one shouldn't know about that at all. All it cares about is values between the byte range or 0 and 1. So we're going to remove this one here. We don't care about sending it in here or nor here. And then again, we don't need those. Okay, so it's way cleaner now. What do we have? We have data primary, data secondary still. We're gonna get to that one. We have two constructors. And I just want to order them like this instead. So we have one constructor where we send in width and height. And here we just instantiate data. We have a second one where we send in a texture 2D and a blit material. And we also call this one, and then we set the terrain data as well. And then we have one where we generate the texture. Right now we just generate it like this, with a Perlin noise texture channel value generator, and then constant value for the other ones. Get resolution, get index, inbounds. Get data array, get data information. Get resolution, get index, get data array, get data, set data, alter data, apply data, set terrain data. I think we want to go private. Instantiate data as render texture, and then lastly this one. Okay, I think this is starting to shape up. Slowly converging towards a a nice constant abstraction of the data underneath. I like it, with good entry points. But okay, with a lot of changes we have made here, we're gonna have a lot of errors, and I'm just gonna step them through one per one and fix them. Clear, yeah, here we go. A lot of them are related to fluid, but we're gonna start with terrain patch. Yes, okay, so recalculate terrain patch mesh at index. Here we asked for value. This one makes me wonder one thing, I think. Let's see here. Terrain data container. I'm just gonna check. Value. I'm a little bit worried about this one. So what we're doing here is we're calculating, or we're fetching values to properly be able to calculate normals and tangents. But I notice now that we take the 0, 1 value while we work with a delta value here, which is in world space, I think. So I wonder if we have to do double check if world space height is redundant in because when we actually calculate the normals, we do it by a very simplified equation. The initial equation is it has a lot of terms. It's basically the cross product between up and upright, cross product between upright and right, and we go all around, we add them all together, and we simplify. I wonder if the actual height would get cancelled out in that case, or if we need to take it into account. Although this has yielded pretty good results. But let's see here. So what we want to do instead here right now is we don't want to use data index. And also, one more thing. Might as well. So we want to replace this one with, let's see here. First of all, we're going to remove this. have it in 8. Get data and terrain data type dot height. Although I wonder... we're gonna do it like this. What did I miss? Oh, we had it in one other place. That's not good. Mesh data length. And then we have this one left, terrain patch, height range, want to remove that one. And now what we have left are purely fluid related stuff. Let's see. Here we probably want to have set data, we have byte value, alter data, we have int value. Here we have one sec. Yeah, here we have int value. I also want to add one that is public void set data. But we're going to have a float value. And we're going to assume that this float value is between 0 and 1. So here we're gonna have a set data y. We're gonna cast it to a byte, and I think we're gonna do math inverse lerp between 0 to 55 and value. Yeah, so what we need to do here instead is terrain patch, terrain data, set data, and what is this one? Set raw fluid amount, terrain data type, water. Here we want to set raw height plus fluid amount. It would be nice to have some more functions when it comes to adding different data and stuff like that, but I think yeah, we want to set data, and the data we want to set is get data height x, y plus fluid amount, I think. This is also something we need to fully specify. Like the water amount in terrain has represented both water amount at a pixel and water surface height in a pixel. I think it's going to be the latter eventually. So the one we're adding here and here. Terrain data in bounds, and what we want to do here is Okay, beautiful. One more thing, however. I'm a little bit... I want to try if everything still works as it did. But before we do that, we need to go into terrain data container. And fix this one. So I wonder... data primary, instantiate data. For now we're going to do data is equal to new clones. Yeah, probably gonna do this. So could we do data 1 is equal to wonder if we can just do it like this. What's up, Norin Dev? How are you doing today? Something like this. Although I would like to clean this one up in such a way that terrain data type controls it. a bit sick. Get well soon, man. I'm pretty good. Nothing to complain about. Okay, and then instantiate data as render texture. So this one, we could probably, yeah, we're gonna assume 100% at all times that these two are the same sizes. So when we do data primary width, we might as well do this. What's up, Kendo? Keep it up. Yeah, I'm trying. I appreciate it. And then we have set terrain data as well. We're gonna add a type here. And then we bleed new data into data as render texture. Yes, and here we do data type dot texture index. We're gonna do it like this. Yeah, this one we want to go through as well, but first of all I'm gonna do, where am I? One sec. We can do this one. Alter, or actually no, we're gonna do this one last, because when we do this one we're gonna have to alter this one, but that's okay. Whoa, 1 sec here. I might have screwed this one up previously. Generate texture content. What's up, Cool P Gaming? What's the game genre? That's a hard one. Like, it all depends on how specific I want to be in my answer, but think simulation, think Tamagotchi, Chow Garden, Viva Pinata. Okay, so when it comes to if we generate the initial textures, which we're not gonna do later on, fuck, I'm a little bit worried about this one actually. Let's see. For now, we're probably going to keep it like this. And then we're also going to do Coolpig Gaming, are you thinking of releasing this game in the future? Yes, I do. But it's gonna be a while. Okay, so if we instantiate with this one... let's assume it's height at all times. Okay, so now we only need to fix this one, and then we can try, after having pretty much redefined this one, will everything work as it did? Hopefully. So this one here, alter terrain data blit, what we basically do is we send in terraform data. Terraform data includes which area we're gonna terraform, the different ranges of the points and stuff like that, and then we send in terraform brush. And yeah, much like in Photoshop, for instance, terraform brush defines brush size, strength, texture. More specifically, what do we have? Material, radius, height. But what I'm interested in is mode here. Terraform brush mode. If we go to this one real quick, we have alter mesh. Fuck, we have a few. Like, I would love to replace this one with terrain data type. So we want to add a terrain data type to our terraform brush. But we have a few methods here. Alter mesh. I think terraform grass. Yeah, this one we have color right mask. This one is this one we can move to terrain data type and it will work. Cool P Gaming, what engine you're using to make the game? I'm using Unity. This one we can move. This one we can move. This one we're gonna move to Terraform Brush. This one we're gonna move to Terraform Brush. This one we're gonna move to Terraform Brush. This one as well. This one as well. This one as well, I think. And then we have change here. Yeah, this one we're gonna move as well. Let's do it real quick. So we're gonna start with this one we already have. We're gonna start with this one. Actually, this one we already have, and that's good. If we take a look at terrain data type, so color channel here we have channel index instead. So this one we already have. This one I think we're unfortunately going to have to implement with a switch case. I think it becomes a bit clearer instead of doing some recalculations. So red here has a value of 8, green has 4. That's not really what we have here. Cool P Gaming, looking forward to making a game also, just need to learn how to code. Get on it, man. It's extremely satisfying making games. I guess it's subjective, but I do really enjoy it. So we're just gonna take this one, and terrain data type we have as string, and we're gonna add a function here. And we're gonna change it to as color right mask. I'm gonna do type. And we want to replace terrain data type. So height and terrain data type dot water is both gonna write to the red one. Foliage and previous. Then we have unused 1b, unused 1a. We have influx and timestamp, so we're gonna do influx writes to blue. And timestamp writes to, let's see if we have it. Alpha. Oh, that's not the one we want to change. Color right mask. In fact, do I want to do this? Let's keep it like this. Okay, so if we're working with the color channels on the CPU, then we use traditional indices. If we're gonna work with it on the GPU, we add color write masks, and we can alter our shaders to only write to the specific ones. Okay, Terraform brush mode. Change, I also want to do this one. So change though. So basically this method is just a method for if we have height, for instance, and we want to increase one, we get foliage. Yeah. And we can decrease also. It's like we want to be able to step through these basically. And we need max as well. Okay, if we introduce a max method here, or I wonder if we can do last timestamp, and then we add first. But change. I would love to call it like increment, but we're having a sign here. Do we have a good word for increment, decrement word? What the fuck? Okay, if that is true, might as well. So before we continue with Terraform brush, I just want to jump back to terrain data container, because we can clean this one up a bit. And I think I want to do like here we're gonna do terrain terrain data type methods dot last and we cast it to an int. So in this case we're gonna get timestamp. Timestamp has a value of 7. We cast it to an int, and divide it by 4. Like this. So we know that each texture holds 4 channels. We have X amount of data types, and we want to figure out how many channels, how many textures. If we have X amount of data types we want to store in textures, how many textures will we need? And then we're going to instantiate the first one, but we're going to add a failsafe. If data.length is bigger than 0, or actually return like this. And then we do for each texture 2D additional data in data. We want indices here actually. And one more thing, we don't want to start at 0, we want to start at 1. And then we do I. Offset, bounce, and default and resets. We're gonna have in brush. But alter mesh we're gonna have in terrain data. But I want to rename it. Let's see here. We're gonna change it to is mesh dependent. For now, I think it's only height that is it. But that might change. Okay, terraform brush mode. wonder how. Let's see. And then we jump to Terraform Brush. Alter Mesh, Mode Alter Mesh. Yeah, we're gonna change this one to Mode. Good morning, E-Dragon, by the way. And what's up, Derek? Still refactoring things. Yes. Unfortunately, yes. Although I'm one of those people that actually enjoy refactoring. I think it's nice. It's soothing, you know. Might not be the funniest stuff to watch, though. Brush. Oh, do I want to rename this one Type? I think so. Terraform Brush. But I'm gonna do this. We're just gonna write it like this. We're not gonna change everything because we're gonna go through them and alter them. Terrain data type. Ooh, is that so? Using, no, not using, but namespace. Refactoring and optimization is always nice. I agree, E-Dragon, I agree. The feeling when you optimize something and you finally do the optimization test and you get that performance gain. That is nice. Okay, so alter mesh, we use this one, but I want to see where. Terraform brush, yeah, if alter mesh, I wonder, type, yes. We're gonna jump to, we're gonna jump to this one. Terrain patch terraformer. I think this is clearer than obstructing it or obscuring it with this one, because this is pretty straightforward. But if it would be alter mesh, I would have to jump to this one. Yeah, we're gonna lose that one. Derek, I only enjoy it when I know for sure the refactor will make it more performant. Okay. Yeah, that is also like, so the opposite of seeing the performance gain you have been wanting is, that sucks. Yes, it sucks. In a few cases, I've actually, I remember I did something, this was a few years ago. I did something related to like optimizing neural networks, and did it by... So neural networks, when I did work on them at least, they were pretty much just big matrix multiplications. And a lot of them still are. But we try to optimize a neural network by analyzing the neural network, see which parameters weren't used that much, and then we prune them. I don't remember the paper that did this first, but it was very nice. So eventually you want to do, instead of having a neural network that is entirely made up of matrix multiplications, it is a neural network that is entirely made up of sparse matrix multiplications. But the thing with sparse matrix multiplication is that you don't get any performance gain unless the matrix is sparse enough, which means that if you don't find as many parameters in the neural networks you can remove, you won't be making these sparse matrices sparse enough, and you will be getting a performance hit instead of a performance gain. And the first time I came across that, it was extremely depressing. So rewriting a full system using sparse matrices, which took a lot of time, and getting a performance hit as a result. That was rough. But hopefully, so the thing with this refactor we're doing here, it's actually a trifecta, I would say. We're going to get a performance gain. We're going to get much, much cleaner code. And I love cleaner code. But we're also doing this to enable doing some visual bells and whistles. I'm really enjoying the thought of implementing. Derek, the ray marching asset I'm working on, by the way, looks really nice. I guess, or do you use ray marching for the SDF, right? Has been a massive challenge because I want complex scenes of many SDFs, yeah, exactly, to be possible. But of course, ray casting for each pixel is extremely expensive. Yeah, unfortunately, it is. It is. So what is the solution for that? So if you rely on my initial idea, is, so you're gonna have to rely on SDF bounding boxes, right? But that still means that in a worst case scenario you will have bounding boxes on each pixel in the scene or in the frame, so you're still gonna make ray marching for every pixel. But yeah, eDragon clean code is so satisfying. Yes, indeed it is. Although the definition of clean code varies, I've noticed. Was thinking of refactoring my game jam code, but too much technical depth. Yeah, I can relate to that one. Game jam games is, do I dare say, always a mess when it comes to code. But yeah. By the way, is the game jam done, eDragon? And if so, how did it go? Did you finish what you wanted? Okay, so what more do we have? We have mode description. Yes, instead here we're just going to do type to, or get, the fuck. Yeah, as string. Yeah, and then we have bounds here. So set brush radius this one, we want to do... So bounds here, what do we actually do? If it's water, we do this, otherwise we do this. Ooh, yeah, that's true. So this is only for water. This one is very specific. We're gonna do private range. If it's we want to do switch on type, and we do case we just have radius there. No, brush radius range. And then for default, we just return brush radius range. Derek, having to learn complex techniques like bounding volume, hierarchies, and recently implemented a cone marching pre-pass, which all allows for huge render distances. But the shader takes 10 minutes to compile. Damn, yeah, that's when you know you're working with complicated stuff. Either that or you've done something wrong, but usually, or hopefully the first. Okay, that makes sense. I've heard the terms B-boxes so many times. I've never myself have needed to done anything with it. But yeah. Yeah, bounding volumes for complex volumes. Yeah, that's insanely complex. Okay, B boxes are just short for bounding boxes. What is the term I'm looking for then? Could it be... Oh, is it bounding? I remember something similar when it came to like Bezier surfaces or something like that. eDragon 6 days until the game jam voting ends. I'm happy with the end result, even though it was rushed at the end. That's usually how it goes, right? Feel free to post the end result in Discord if you haven't already. Okay, so here we're just gonna do Mode.bounce this one. We can just do this instead. Get type bounce clamp radius. A little bit cleaner. And then we have change brush radius. Here we do mode bounce again. So get type bounce. Change brush mode. Here we're just going to do type increment, I thought. Did I screw up? Increment. Ah. So we do like that. Brush material set int, yeah, type, color right mask. Resets radius. Yeah, right now we only have default radius 0.1. Resets radius. 1 sec. We don't need this one, or do we? Instead, we're just gonna do set brush radius. And then we have reset strength, set brush strength. What do we have here? We're just gonna do this, I think. Okay, this is great because now I think we can go to terrain data container and we can change this one a little bit. So terraform data, we're gonna do data as render texture, yes, and then we're gonna have to work with this one or be a bit more specific with this one later on. We're gonna do make it fully work with data. Yes. We're going to do texture 2D data texture data, and here we do terraform brush dot type dot texture index. So then we get the correct data texture, and then we do read pixels, height, and then apply. Okay, beautiful. I'm not... Okay, we have a few more things to fix. Oh, we have offset as well. Terraform brush. Int. Something like that. And then we have color channel, and we just do type. Oh, color channel. We can clean this up a bit as well, I think. But let's see here. For now, we're just gonna do texture index. What's up, Ashiru? Yeah, terrain patch we can clean up a bit as well. Oh yeah, we're gonna have to set the correct textures, that is true. We have this one as well. We're gonna clean this up eventually as well. Generate terrain data. How do I want to handle this? So basically it's going to be, we have a few different materials that are going to render the terrain, the water and such. And we want to set the correct texture references in the shaders. Ground mesh, water mesh. Yeah, we're gonna fix that as well. The relationship here is I think the easiest way and cleanest way right now without doing an additional rework would be to do set material texture, and we just send in I guess we could do probably do terrain data container, get data, get data array, although a little bit unclean, but yeah. Terrain data, get terrain or get data texture for terrain data type height. Not entirely sure about if this is the way I want to do this. Okay, interesting. Is it gonna run? Hopefully. the did we get a okay, could be this one. That screws us. Terrain patch 161. Generate data 161. Type texture index. Oh, I would love. What's it? Get terrain here. I wonder if I would have made a mistake. With the division here. So when we divide integer with integer, it returns. I thought it would return the value closest to 0, wouldn't it? 0, 1, yes. Okay, so that's not a problem. The problem could be that data isn't instantiated. Oh, yeah, not divided by 4. But well, actually, it is divided by 4. Or yeah, so divided by 4 will yield 0, 0, 0, 0, 1, 1, 1, 1, 1. Yeah, so that is the correct. Instantiate data here should give us timestamp value of 7. Where do we have terrain data? Should instantiate it here, unless this one. Of course. +1. Yeah, this one. Yep. Can actually do last. We don't need to divide here. Instead we do last dot get we do last dot get texture index +1. So the last terrain data type, what texture index does that one have, and then we create that index +1 number of data textures. I hope. Okay, this is making me a little bit nervous. Very nervous. Last returns timestamp. Timestamp will return texture index. So we have 7 here. 7 divided by 4. Okay, that's very weird. here we have something at least. That's the water. And where do we have ground? We have ground here as well. Here's ground. Oh, interesting. This one I'm interested. Set brush radius, yes. Okay, it's because we called this one before it has been set. So set brush radius, and here we do brush visual object, but we haven't instantiated it because of this. So yeah, of course we want to instantiate these first. Still a little bit worried about the time it took it to run. So the last thing I'm gonna do today, we have something. I think the textures, yeah, the instantiation of the data textures, we have something wrong there. It takes way too long time to generate these textures. Or way too long to make the mesh represent those textures. And I might know why. But unfortunately, that is going to be the first thing I fix tomorrow because I gotta run. But, as always, thank you so much for watching. Appreciate it. And have a great rest of the day. Peace.